So, and let's just summarize and try to describe in numbers. Okay, the computer in Midas and every computer software do not say that which is belong to x-axis, which is east to west, and which belongs to y-axis, north-south, for example, which period belongs to torsion. The computer just lists numbers, for example, 10 second, and longest, starting with the longest, as I said, right? It lists from longest period, 10 seconds, say maybe next 7 second, 5.7 second, 3.2 second, and 2.1 second, something like that. So it just lists from longest, biggest number, longest period to shorter period, as you see right there as an example. It doesn't say whether this belongs to east to west, this belongs to north south, and this belongs to origin. It doesn't say that. But we can imagine in general how the numbers are summarized, how the numbers are listed. So this is x1, for example, and then you go next, possibly period and most shape it's gonna go with the other direction, which is y1, and then torsion. So mostly, if you have a regular building, something like that, very well defined regular building, then you probably have this sequence. You start with a x1, which is okay. Let's see. This is x. This is y. Say this is east to west, north south, and which one will give you period for x-axis, y-axis? Which period will appear the first? Okay, we remember that the more flexible, and period is longer, right? The flexible structure will give you the longer period, and the stiff structure will give you short period. We know that, right? So each will give you long period. If you see over there, and this probably directions, we have a lot of words here, right? Longer words than this direction. Right? So this direction looks like stiffer. And this direction looks like flexible. Understand? Why is flexible? Why flexible? This direction looks like shorter words, smaller words compared to this direction. This direction, we have a big words, longer words, larger words, so that the period we are expecting from this type of building is going to be longer with this period, right? Because this is flexible. So let's say TX is longest, and Y direction is less longest than the first one. So it's possibly we see X1 first and Y1 and then Z1. We're gonna put sub X1, X1, Z1. The 1 means here represent the first mode. Okay, first mode. And 2 here means or indicates denote second mode, right? So in this type of regular building, we can easily find out which direction will give you longer period or shorter period, so that you can take a look at what is the longest period and came from which directions, right? Okay, let's say if you have a building, something the other way around, then you have a X and Y don't change, right? Okay, then your number nothing more than just one series of number is provided by the computer. In this case, this is more flexible, right? Because of x1 instead of x1, y1 appears first as longest period y1. Okay, y1 and y2 and x and z. So it doesn't change, right? It doesn't change. And next y2, x2, z2. It doesn't change. So y appears first. Why? Because the y direction is more flexible. So it will give you the longest period or longer period than that of with x-axis. Okay, so it is just numbers in output, minus output, but we can take a look at which belongs to which mode. First mode is probably belongs to the directions in which more flexible structurals are placed or designed. If you have, then what happened then? Exactly same side in both directions, called a rectangular building. The rectangular buildings, assuming that you have a similar amount of walls in both directions, x and y directions, then it's easy to think that x1 is about to equal to y1. Right? It's easy to think about. And x2 is going to be similar to y2. Right? It's easy. And x3 is going to be y3. Okay? So with a rectangular buildings, it's hard to tell the differences between directions as long as they have a similar stiffness in both directions. Then they're really the same number you're going to find out in computers, right? So if you see the computer, then computer is going to anyway, it's going to give you one list of lines, but computer says like 10.2, and next one you're going to say 10.1. They're all same. So if you see x1, the first line and second line are very similar, then you're going to say, okay, this is one direction, this is another direction, right? Oh, they're same, which makes you think that this building is rectangular because they're having a similar stiffness and similar dimensions of the building will give you a similar period. And then torsion is going to be different, right? So this is going to be TX1 and T1 and T2 and 4, 5, 6 and T1 and T2 should be very close, very similar if this is a rectangular building, or a T1 is longer than T2 if T1 directions possess flexible behaviors. And same thing here, right? But this is similar for rectangular building, or this can be bigger otherwise. So this is what you see computer outputs. Okay, but the question arises that, as I said, will this order follow? Mostly. My answer is no, because I'm just giving you a very straightforward, a standard example where we have a very nicely looking building, rectangular building exactly, and square building exactly. And if you have beautiful square or rectangular buildings, then this rule will apply. This rule will hold. There is no doubt about it. But most buildings not like that, as we wish. Like that, some buildings like that. Some buildings is even complicated, right? I don't know. Maybe it depends on property line of the land. Now in this case, it's very hard to define clear cut between the period. So some periods are combined here. X1, TX1, and this is TX2, TY2. If we have a beautiful rectangular looking shape, right? But it is not. It is not a rectangular building. It is some weird type of buildings, and maybe this building natural frequency and period are mixed up. So maybe the building is going to behave mainly with that direction, slanted direction, skewed direction, 45 degrees, and you have a 45%, half influence of T2, TYX, and half influence of T1X. So your building mode that Midas will give you with this direction will probably mix these two period up. So, and torsion as well. So in that case, all this order is not found anymore, right? So you should be very careful when you take a look at this order. You should be very careful taking a look at your building shapes as well, all right? And it is, do you follow me? Everybody follow me? Yeah, I'm trying to speak as slow as possible for all of you to follow. But if not, don't worry about it. When you run the Midas, running your building projects, then you will understand what I said very clearly and very easily. All right. So send me your questions, your inquiries through the bulletin board in eCampus, or you can send me emails and I will answer in the class as well for all of you, right? So don't be just left behind, because this is very important stuff for you to understand high-rise building.